All right, it says we are live. Give it a minute. Let's see. All right, folks are starting to roll in. All right, hello to everyone out there. We'll get started here in just a second. We're letting everything take its course. And I see people rolling into the room as we speak. As you come in, there should be a poll on the right side of your screen. We're just interested in, have you used Cosmos DB before or some sort of DocumentDB database? Sidney, you said or DocumentDB, but do you mean DocumentDB or just kind of NoSQL in general?
If you know what DocumentDB is, you can click yes, because that's very confusing right now with the rebranding.
Awesome. And also, if you want to, we have the chat open. You can chat during the entire session. And if you click on the little chat bubble, there's a chat or ask a question. So if you have a question throughout the presentation, feel free to ask your question. And if it's something that we can answer right away, I'll interject and I'll ask Sidney on your behalf. And if not, we'll have plenty of time after the presentation for Q&A. And those of you who are watching on the replay, you can still ask questions, and those questions will get emailed to us, and we'll still try to get your questions answered. So if you're watching this days and weeks after this webinar happened live, which today is August 23rd, so if you're here on September 4th, and you have a question, still ask us a question, and we'll make sure that you get an answer to it. So hello, Joel. I think I know who Joel is. All right, Sean. So I think I know who Sean is as well. Hello, everyone out there. We have a bunch of folks rolling in. It's 1 o'clock. So I'm going to go ahead and kick this off, and we'll let Sidney do his thing. All right, so hello, everyone. My name is Kevin Griffin. I am the owner of SwiftKick. We are a software training and consulting company based out of Chesapeake, Virginia. You are in our very first of many SwiftKick webinars. So my career has been built out of giving back to the community, doing user groups and conferences and different types of events. And I really enjoy the format of a webinar. They're a little less formal than a traditional user group talk. It gives you a chance to get some one-on-one feedback from a presenter. And it's something that we can do for free and bring in a lot of expertise from all around the world. This is the first of many. I already have the next two scheduled, and I'm working on a third and fourth. But our schedule in particular is going to be every other week, most likely on Wednesdays around 1 or 2 o'clock. But if you're registered for this webinar, you're going to get notified about those, and you'll have the option of signing up for them if you want to. Like this event, if you can't catch it, but you still register for it, we'll send you the replay. And as I mentioned a little bit earlier, you can ask questions during a replay, and we'll make sure you get answers to those questions. Down at the bottom of your screen, the bottom right-hand corner, there is a poll. Have you used Cosmos DB or DocumentDB in the past? And just a yes or no, if you could answer that for us real fast. Also, we have the chat up and running, and you can chat with us. I'll be watching the chat. Sidney won't, because he'll actually be doing work. But let's have a conversation. If you click the little chat bubble next to the chat box, you can also choose to ask a question. Questions I'll ask them as they come in, if it's a good time for Sidney to pause. If not, we'll hold questions till the end of the presentation and we'll try to make sure every question gets answered. So without further ado, Sidney, Are you all set, sir?
Yeah, I'm ready to go.
All right. We want to roll your video first?
All right. Well, I'm going to quickly just, thanks, Kevin. I'm going to introduce myself and roll the video. Welcome, everybody. Really excited to talk to you about Cosmos DB today. Cosmos DB is something I got on the ground floor with back when it was named something different. And it represents a paradigm shift in the way we work with databases or work with NoSQL data structures in the whole Microsoft stack. It represents a paradigm shift in just database technology that comes from Microsoft, period. To me, it represents an alternative to the traditional, we're going to set up a Microsoft application, let's set up a new framework in SQL and get going. It gives us an option that has a lot of flexibility and a lot of power that just simply didn't exist before. So first, I just wanted to give you a quick run through of what the Microsoft team thinks, what they think you should know about Cosmos DB. Then I'll introduce myself. I will do a very few slides, and I really want to get into a portal and show you what Cosmos DB is and why I think this is groundbreaking and potentially career changing for people, especially people who work with Azure, work with the Microsoft stack, work with database systems, and even people who don't work with that stack. So first, I just want to roll the very, very quick video that we use when we introduce Cosmos DB to anybody. So
imagine a horizontally scalable database that puts data everywhere your users are. It seems intuitive, but most databases are still light years away from true turnkey global distribution. Azure Cosmos DB offers the first globally distributed multi-model database service for building planet-scale apps. It's been powering Microsoft's internet-scale services for years, and now it's ready to launch yours. Only Azure Cosmos DB makes global distribution turnkey. You can add Azure locations to your database anywhere across the world at any time with a single click. Azure Cosmos DB will seamlessly replicate your data and make it highly available. Azure Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the throughput and storage you need, anywhere in the world at any time. As the first and only schema-agnostic database, Azure Cosmos DB automatically indexes all your data so you can perform blazing fast queries. And since no data is born relational, the multi-model and multi-API capabilities remove the friction, allowing you to build with any data model and API. While most database services force you to choose between strong or eventual consistency, Azure Cosmos DB provides multiple, well-defined, intuitive consistency choices, so you can select just the right one for your app. Take off with confidence, knowing Azure Cosmos DB provides guarantees and comprehensive SLAs other databases would never attempt. High availability, consistency, throughput, and single-digit millisecond latencies at the 99th percentile. Your app deserves a globally distributed database service that's out of this world. Welcome to Azure Cosmos DB.
Showed you the video about Cosmos DB. I don't work for Microsoft. I'm not a salesperson, but I'm super excited about this platform because what it represents is you probably heard in the video schema agnostic. It represents a database that doesn't depend on a specific schema or depend on a specific API. The idea with Cosmos DB is that they gave you a ground level of functionality and feature sets that are guaranteed no matter how you want to access the database or how you want to structure your data. So for applications that need to be globally distributed, that means I need a data center in Europe, I need a data center in US, I need a data center in Australia. That's built into the base framework of Cosmos DB. If I need more compute, if I need more storage, that should just be an option. That shouldn't be a project. It should be the elasticity should allow us to just go and say, you know what, spin up 4 times as much storage as I have now. I need 3 times as much compute as I have now. I should be able to go select that as opposed to planning a project and hoping for the best and trying to guess where things go work. It should just be a completely elastic managed option. Latency-wise, Cosmos DB was dogfooded by Microsoft. So they've been using it for many, many years internally under different code names. So they've been designed this database to be extremely fast. They offer SLAs that guarantee single millisecond latency. And it's something that is one of those things that it's not so much a sales thing as much as you can go in, check that latency against your own application, and then they have that financially backed SLA. So if they don't perform to what they promise, then there's a financial compensation for that. And then the whole end piece of all this is that you have a highly available database. So you said, Sidney, you're talking about database, you're talking about all these features, but you actually haven't talked about the most interesting thing is, okay, how does this database work? And that's what makes Cosmos DB really, really interesting, because it doesn't work in the way that you think a normal database will work. So all these features we just talked about, they are really below the scene. So we're talking about, the global distribution, elastic scale out, low latency, the SLA, all of that's here at the base level, but that's actually for the Cosmos DB internal engine. And they actually implemented a NoSQL database, and that NoSQL database uses a specialized version of Atom to actually store the data. And this data is stored that way because they can expose data models. So you've probably seen other NoSQL databases, like maybe Redis Cache. There's a key value based NoSQL database. Well, Cosmos DB is really structure agnostic. So Cosmos DB can represent your data in a key value fashion. You've probably seen column family. I'm thinking of Cassandra and HBase. I believe HBase is a column family database. Those are column family databases. So normally you'd have to stand up a separate database if you want column family functionality. Not with Cosmos DB. That's just another representation of the data they provide. If you need a document-based database like a MongoDB or Microsoft's DocumentDB, again, it's just another representation of the underlying data that Cosmos DB can provide. And if you need a graph representation, you want to use Gremlin as your query language. Again, just a representation of the data. So what's essentially going on here is Microsoft implemented their own data structure, and they translated essentially in real time into whatever model or structure you need for your data. And then they provide access to APIs that are very familiar. So if you're already using something like SQL query language or for SQL database, then there's a SQL access available for document-based entities using that document structure. If you're used to JavaScript, again, with DocumentDB, MongoDB, you have that available to you. If you have an existing Mongo application, Mongo is just surfaced as an API. If you have an existing graph application, Gremlin is surfaced as an API. If you have an existing key value application, the Azure Table Storage API is surfaced as an API on top of Azure Cosmos DB. So the easiest way to think about this, and this is the one that people always give me trouble for, but the easiest way to think about this is imagine a database where the actual database, how it stores the data, and how you query the data are three separate things, three separate tiers, and you can pick your choice at each tier. So at the very base tier, Azure Cosmos DB provides those 5 features we talked about before, but then you can choose your data structure, wherever your key value makes sense for your application, wherever column family, document, or graph makes sense for your application. And then you can choose your API. Which API really makes sense for your application? If you already have a mean stack application, you're already implementing everything in Mongo, and you're using Angular, Express, and Node, then why not use the Mongo API? If you are implementing a net new application and your team has some familiarity with SQL and JavaScript, then the DocumentDB API may make sense for you. And then for the specialized use cases, you maybe want to do cache storage. That table API may make sense. If you want to do graph traversal, social media applications, the graph and Gremlin API may make the most sense for you. So it's weird, but we're really getting to the point where we're API agnostic. And this gives us the flexibility to support more APIs in the future. You're going to see as time goes by, more and more APIs being added. There's APIs, being worked on already. Now, some of them being talked about publicly, some of them not so much. The idea here is that Cosmos DB is flexible enough that as the open source community decides that there's another API or another query language that makes more sense, the Cosmos DB team can just implement the API or implement that query language. You don't have to change your platform. You don't have to re-engineer your database. And that's the easy win. The more interesting thing is that if you think about multi-model applications, and multi-model applications essentially we have them already. We may have an application where we store a lot of business data in SQL, but maybe we store some case management information in a NoSQL database. And so we have an application using both a relational and NoSQL system. But you also see some more multi-model applications. One of my favorites is we may have an application where we have a lot of event management application, think like an Eventbrite or Evite. We may have our event information in something closer to a SQL. No, it's still using NoSQL, but we still like using SQL query language, using JavaScript for our store procedures. So we can use DocumentDB for that. But then when we need to actually make relations amongst events, well, people who are going to this event who are friends with X person and traverse the graph of information, we can use graph for that part of our data set. So essentially, application using a single database in many different ways. And like I said, I want to stay very thin on the slides today because I really want to show you what I mean here. And this is the type of thing that really hard to visualize if you haven't tried it before. So I'm going to switch over to my machine. And so I have a couple of instances spun up Cosmos DB. I have one using DocumentDB. I have one using Mongo table storage and the Graph API. So I'm going to start with the DocumentDB instance that I have. I can go in here and it gives me a little, hey, do you want to get started, add a collection? I'm not going to worry too much about that. What I'm going to do, and I have no luck, let me refresh the browser real quick. What I want to do is I want to access this. And we looked at some of the information about people attending this session. So saw that many of you already know .NET pretty well. So we're going to start with a .NET example. So I'm going to zoom in on this. I'm going to add a collection, and I'm going to call this collection people. And then there's a billing aspect to Cosmos DB. We're not going to go too much into billing, but essentially, I'm going to lower it to the slowest speed possible, so I pay very little for it. Again, this is just a demo database, so I'm using a fixed storage capacity instead of an elastic storage capacity, and my request units per second. That's essentially your measure of how many requests you can make per second. I'm minimizing that because in this demo application, I'm not going to hit 400 request units per second. For my database, I'm going to go in. I'll just give it a name, example database. And I'll hit OK. And I've created a database and a collection. For those who are interested in billing aspect, you bill per collection. A database is really just a set of collections, more for logical structure and storage. It can be really interesting if you have, let's say, 6 collections and you want to give somebody access to 3 collections. You may want to put them within the same database. It's more of a logical thing. Now that we have this collection set up, I'm going to go, and instead of using Visual Studio today, I'm going to use LinkPad. I think it's just a little bit faster to get things done. I'm going to go ahead and I'm going to say string URL equals. I'm going to go get my access information. So I need a URL and an access key. If I switch back to the Azure portal, I go to keys. I see my URLs right here, and I'm going to regenerate these keys after the webinar, so I'm not too worried about if you see them. So I'm going to go in here to LinkPad, and I'm going to paste in this URL, and I'm going to copy one of my keys. They have the option to regenerate, and for most Azure data services, they give you multiple keys. That way you can create a key regeneration strategy that makes sense. So I'm going to copy the secondary key, paste it here, and then I can use the DocumentDB NuGet package. So here I'm going to go to NuGet, and if you just search for DocumentDB, you'll see it. I've already added it to this application, but it's the Microsoft Azure DocumentDB client library. That's what you really want. Now I need to give it a database name and a collection name. So a database name, if I remember correctly, is example database. And the collection name is people. I always double check because I forget sometimes, but I believe for some reason I have a bug with my browser, but that's no big deal. Yeah, we have the people collection and example database. Right now it doesn't have any documents in that collection. I could go in, create a DocumentDB client. So document client equals new document client, pass in a URI using our URL, pass in the key, and then that's it. We have a client. Our client allows us to do things like create database if not exists, And then we pass in the name of our database. So we'll say new database ID equals database name. And we can do the same thing with collection. So client.create document collection if not exists async. I was not going to try and spell all of that out. This time we're going to use this special class called the URI factory to create a database URI for ourselves. So we're going to create a database URI using our database name. And then new document collection using our collection name. Now you may say, why are we using this new document collection, new database class right here? What it does is it checks to see if that database and document collection exists. If they don't exist, it's going to create it, and it's going to use whatever settings you provide here. So if you have some customizations, like maybe you want to set a partition key or set things like throughput, you can do that here. I've already done that. It's going to find the existing items, so I don't need to worry about that, but that's just something interesting to know. So if we run this, query is successful. That means we can actually, everything's good. I didn't have any typos. So how do we add something to DocumentDB? Well, you can add anything. It's really just JSON. So I can just create an object in C#. We'll call it payload. So instead of new object, just do new curly bracket, first name, Sidney, last name equals Andrews. If I could spell my last name today, that'd make it even better. I'm going to go in. I'm going to call client.create document. You notice everything's an async method. That's a good thing here. This time we're going to use URI factory again. We're going to create a document collection URI. So we need a database name and a collection name. So database name, collection name. That's how we tell it where to create the document. Then what we want to create, our object. So I would say payload and run it. And I created a document. So you notice I didn't have to have any special classes or anything like that. Because really it's just creating JSON and sending that over the wire. It's really just a post, if anything. So we have our new document here. Since I didn't provide an ID, DocumentDB generated an ID for me. I can create another document. Maybe I'll use my wife's name this time. It's schema agnostic, so we can go in, add more properties. So age, my wife's 32. I can even add an ID. So ID equals Brittany-Andrews. Run it again. There we go. Go back in here. Refresh. So you see it's very low friction to get started. You see that I have my wife's. I specify an ID. Oh, I used uppercase I in ID. I should have used lowercase I. So let's try that again. I made a mistake. No worries about that. I'll use my brother's name. Run it again. There we go. And we'll see I've specified the ID here, has the same properties. We can do all sorts of interesting things. So this really just, we have CRUD functionality that we have in a regular database, but things start to get really interesting when we want to add in more features. One of the things I like to show off first is querying this. This is where a NoSQL database becomes interesting, because by default, all of those documents are just JSON. So we don't know what properties there are. We don't have a schema. So it indexes everything. So out of the box, I can go ahead and start querying. So select person from person, maybe person.star, run query. Actually, I had the syntax wrong. My apologies. Select star from person. So you see you got all three people back. Maybe select star from person where person.age is greater than 30. It's going to automatically know not only to check the value, but to also go, in and filter out anything that doesn't have the age property. So, you know, the portal is what it is, but all of this is available via REST API. So if you want to just run queries against it, there's SDKs available for multiple languages. We can do it right here in .NET. So we want to take the same query I just wrote and go in here and say, let's see, client.create document query. And then we can go in and say, maybe specify a special type. I'm just going to say dynamic. And then in here, do the same thing we did earlier, UI factory. create document collection URI, database name, collection name, and then we need to pass in the feed options. I like to pass in feed options and say max item count equals -1. You may say, well, why do you need a max item count? By default, pagination occurs when you create items. So I believe it's 50 by default. So if you have a result that has more than 50 items, it's going to only return 50 and metadata about how to get the next set of items. This is not something I would do in production, but for just an example, I'll set the feed options to not have a maximum. I'm going to store this query. So I'm going to say var query equals, and I'm just going to dump the results of it. This is just nothing but really not queryable. Yes, this is when I ordered that queryable. So I'm able to get all the items because they're dynamics brought in as query results. If I want to go in and add a C# class, so maybe public class person, public string first name, public string last name, public int age. I could definitely represent this. So let's see, public string ID. And instead of doing dynamic, I'll just say person, dump the query. There we go. I have my person entities. Somebody say you're using a query syntax just like DocumentDB, but I guess I missed the point where you picked the DocumentDB API. When you create a Cosmos DB instance today, you go in and you say Azure Cosmos DB, you create a new instance, and at this point you pick the DocumentDB API. I'm very careful with my terminology because I say today. One of the last demos I'm going to show you is that you can actually cheat this. Right now in the .NET SDK, you have multiple APIs available to you simultaneously, and we're going to jump right back to that. But let's say I pick DocumentDB API, I can actually create a graph query traversal over documents within the DocumentDB API. We'll get right back to that. But great question nonetheless. We have our query right here, and since it's just linked, I can just say, let's see, query.where person p dot, I don't know, age is greater than 30. It'll dump the result of that. F5, and I only have my wife. Let's see, greater than equal to 30. I have my wife and my brother. And remember, I'm not included because I didn't include myself, an age property for myself. If I just go back to query.dump, you'll see that I have the default value for age. If I really wanted to make this accurate, I would make this nullable. And there you go, I have a null value. So it goes to the default value for the type. So it's smart enough to understand how to parse this into LINQ. And underneath the hood, it's just using JSON.NET. So if you already know JSON.NET, you're pretty good. So DocumentDB is pretty simple to get started with. What I really want to show you is how we can actually use other APIs. And again, this is just an hour webinar, so we don't have time to go into every API. But one that I get a lot of questions about is the Graph API. DocumentDB, you can pick up pretty simply because the syntax is very much like SQL. If you want to write a storage procedure, UDF, you can do that in JavaScript. Everybody has a strong handle on that. But Graph is just completely left field. So we're going to go back to our VM dashboard, and I have Cosmos DB Graph. And I created this, again, using a new Cosmos DB instance, and I selected the Graph API. So I can add a graph. You notice I still have a database name, so I can say demo database. This is actually, for your information, this is a completely different. I'm having a really weird bug with my browser right now. So I'm just refresh my browser real quick. Not sure what's going on. All right, so I'm going to add a graph. Or even better, I'm not going to add a graph. What I'm going to do is I'm going to do this in C#, like we talked about earlier. So I'm going to go back to C# statements and take out all this code related to DocumentDB. And you say, well, Sidney, you just said you took out all the code related to DocumentDB. I still see your URL, key, database name, collection name, document client, all that. Well, the answer is that the Graph API uses the same SDK classes. So if we go to NuGet and we say azure.graph, and include pre-release, we'll see that we have the Azure DocumentDB Graph Gremlin Client API, which is considered in preview because there's graph services in preview. That adds everything you need for both DocumentDB and Graph. So here I can go in and start to do some interesting things. So what I'm going to do to start is I'm going to introduce graphs in the context of Gremlin. So going back to my slideshow, let's see if the drawing works on the slide this time. Go to white screen, go to pen. So it looks like I have a little bug with the way PowerPoint's working for me right now. Let's see. And I apologize about this. For some reason, drawing's not working in PowerPoint, so I'm going to go to Notepad. So we have within, actually, let me open up Atom. Atom lets me zoom in so you can see it better. So with Graph API, we have both vertices and edges. The interesting things about vertices and edges is that we have our vertices are really nodes or dots. Our edges are lines. And I was going to draw this out, but as you saw earlier, drawing is not working for me. So what I'm going to do is I have an example I want to show you, and that's really with people and knowing each other. We might have two nodes. We might have the Sidney node and then the Kevin node. Now think of these as if this was a subway map, stops on the subway map. Now, connecting Sidney and Kevin, we might have a line. So we might have a line that says Sidney knows Kevin. We can have additional lines. Maybe Sidney worked with Kevin in the past. Maybe Kevin knows somebody but has not worked with them before. So maybe Kevin knows, I don't know if Kevin worked with Joel before, but I know Kevin knows Joel. So we essentially have three nodes, Sidney and Kevin, Joel, and three lines or relationships. Sidney knows Kevin, Sidney's worked with Kevin, Kevin knows Joel. We call these vertices and edges. So a vertice might be Sidney, Kevin, and Joel, and an edge, or what you'll see as a line, are knows, worked with, and knows. So let me show you how this looked in the portal. Now I really apologize, I had every intention to draw this out. So I'm going to create a person graph. Same thing, I just want to minimize my cost here for the demo. Person database, it's my database name, hit OK. Once it creates it, I can go to the Data Explorer. Here's my person database. It's loading up every graph within the person database. There's my person graph. So within here, I can start adding different things. So we have our filter. We have no vertices on this graph so far, but I can add a vertice if I like. So I could go in, add a new, new vertex. I'm getting my singular and plural forms confused here. A vertex has a label. They usually, labels identify what type of entity it is. So I'm going to use person for the label, add properties. Maybe an ID for my person is Sidney Andrews. Maybe another property, first name, Sidney. Very much like DocumentDB. It's really not tied to any specific schema. Hit OK. And now I have a Sidney vertex, which is super small here, but it exists. I have the Sidney vertex. I can add another vertex. Let's call this one another person vertex. Unique ID in this, and this is just like DocumentDB. If you don't provide an ID, it'll provide one for you. Let's say Kevin Griffin. First name, Kevin. Last name, Griffin. All right, we can add another vertex. I'm going to just real fast. And this one, I'm not even going to provide an ID. I'm just going to say first name, and I'm going to say Joel. Okay? I just want you to see what happens here. A couple interesting things happen. First, we have our little graph. We have our vertexes. You notice I supplied IDs for these. This one had a GUID generated for its ID. If I close out of here, I can go see different properties of it. So it has label, first name, and ID. So ID is a required property, and it has the two properties I specified. You see the properties here and the properties for Kevin Griffin. I can now define relationships between these. So we start with Sidney. I can define a one-way relationship with Sidney, and I can target Kevin Griffin and add a nose edge. I'm going to add one more. I'm going to target Kevin Griffin again. I'm going to provide a worked with edge. The check mark to save this. And of course, the rule of demos, UI froze up on me. No worries. The good thing about this is that even if the UI froze up on me, I can just go in. And I don't usually use the portal in their day-to-day work. I could go in and just implement this in .NET. So I have my Graph API open already. Same thing we did before. Go to keys, copy my URI, paste it here. Go in, copy my key. And I can use the primary or secondary key. It's really just two to help you out. Go in. I have a database called person database and person graph. So I'm going to go into here, person database, person graph. I have my clients. I can even store them. So var collection equals var database equals. I can use that collection to actually perform Gremlin queries. So I can go in here, maybe I want to add an edge. So I can say client.create Gremlin query. I'm going to create an edge query. Notice it's very similar to the way we do DocumentDB. Pass in my collection, g.v. So for the vertex, Sidney Andrews. To locate the vertex Sidney Andrews, add an edge called nose to the vertex called Kevin Griffin. And the Gremlin syntax, it's actually an open source standard. It's not a Microsoft standard. It's the most popular one in the community right now. So this is something where you can actually go out and study it if you want to do so. So we have our query, and we're going to call query.execute next async. Now, Gremlin queries are also paginated, so to give you ways to actually do a while loop while you still have data, continue to execute next. Since I know this is a very simple query, I'm not going to do all that. But I can just go ahead, invoke that query, and then dump the results. I think I need to await it. My apologies. Run it, and I have an edge. So I could go in here, again, very exciting stuff. Go in and let's see. Go to my graph, show all vertexes. I can zoom in on this, and we'll see we have Sidney Andrews knows Kevin Griffin. So now I have a relationship to Kevin Griffin. The other interesting thing I could do here is I can go in and look up my, let's see, let me zoom out of here. Look up my JSON, see that we have the Kevin Griffin node. I can look for other nodes. So here's Joel's node. I can add a vertex there. So I've grabbed the ID. This time I'm going to say Kevin Griffin knows Joel. So I'm going to go in. Kevin Griffin adds an edge that he knows Joel. And there we go. I added that in. Jump in. Let's apply this filter one more time. And all of a sudden, we have a far more interesting graph. So Sidney knows Kevin. But if I jump to Kevin, Kevin knows Joel. Let's zoom in on that real quick. So now we have a graph that we can traverse. Sidney knows Kevin, who knows Joel. So I can start to formulate queries like, get everybody that Sidney knows, and then find out who they know. Let me show you a really simple query, and I like to do these in .NET because, again, a lot of people who are attending this webinar are pretty comfortable with .NET already, so it's pretty easy. So what I'm going to jump in, I'm going to say, we're going to create a Gremlin query. The first query, we'll start with the simplest query. How many vertices do we have? And I forgot to actually strongly type it, but it worked anyways. Don't tell anybody. So we have 3 vertices. I'm going to go to a little bit more complex query. So get all vertices that has label person. That's our 3 people. Sidney, Kevin, Joel. Looks good so far. Then I can keep digging into this. So I can say, get all vertices that has label person but also has a property, I don't know, last name. So we want to find all the vertices have property last name. So we get only Kevin Griffin. So really simple filtering. Joel says, do you need a corresponding edge to say Kevin knows Sidney, or is there a bidirectional edge option? Today, the edges are single direction, so you would define two edges. You would say Sidney knows Kevin and Kevin knows Sidney. The logic behind it is that those are distinct relationships. And there may be scenarios in your database where you want to say Sidney might know Kevin, but Kevin doesn't know who Sidney is. So I might be a fanboy, and I might say, hey, I know Kevin, but Kevin has no idea who in the world I am. And so by default, the edges are unidirectional, but on user voice, there's a request right now for bidirectional edges. I don't have a strong opinion either way. Joel said, just like Twitter followers. That's a perfect example of a graph. Yeah, you may follow somebody, but they may not follow you. Now, we can also, when we do our graph, our graph queries, we can do things like we can say dot has label values and get the first name of everybody. And so instead of returning a vertex, we'll return a string. Sidney, Kevin, and Joel, that returns everybody. Maybe only the people who has a last name, I want to return their first name and should just get Kevin. So we could do some interesting queries, simple queries here, but things get really interesting. We want to traverse the graph. So let's start with, we want to start with Kevin. So Kevin Griffin. And I want to go out on the nose edge. And I want to find every vertex that's connected to Kevin using that nose edge. So we're going out on the nose edge into the vertex it's connected to. And if they're a person, because you can have the many different types of entities. You can have people, you can have things, whatever you like here. And we want to get their first name. So we want to know everybody that Kevin knows. Run that. Kevin knows Joel. That's interesting, because remember, Sidney knows Kevin, but Kevin knows Joel. So technically, Kevin doesn't know Sidney. I feel really bad, but that's the way the world works. So we're going to copy this, put this in our C# comments, and come back to that. So we're going to add an edge. So for Kevin Griffin, we're going to make Kevin a Sidney fan. So we're going to add an edge called nose, and we're going to connect it to the Sidney Andrews vertex. And I apologize in advance. I always get the singular and plural forms confused. You're just going to have to forgive me for that. All right, so Kevin Griffin now knows Sidney. If we go in here, let's see, let's refresh this. Go back to our graph, apply a filter. We're going to click on Kevin here. Notice we now have a bidirectional edge. Well, technically, it's not a bidirectional edge. We have two edges, but we're representing a bidirectional relationship. So Sidney knows Kevin, and Kevin knows Sidney, and Kevin knows Joel. So we jump in, and we say, all right, our query is, who does Kevin know? Kevin knows Joel and Sidney. So we can start to do some interesting things with this graph, but that's not enough. So I showed you DocumentDB and Graph, which I think is the most applicable you can use in .NET today and get some real benefit from. You can do some really deep queries. There's lots of documentation available on this. But this wouldn't be fun unless we started doing some multi-model stuff. So we're going to go ahead and delete all this. And I have a database here. This is DocumentDB database. And I'm going to create a new collection here. Or actually, this is Mongo. I apologize. I have a DocumentDB one here. I'm going to create a new collection. I'm going to call this collection, I'm going to call this database DemoDB, and collection multi-model. Run it. Go back into the portal. Oh, I actually forgot to update my connection information. That's all right. Gonna update my connection information. Primary key. Pop into here. Let's run it again. No worries. Go to Data Explorer. We have DemoDB. And with the DemoDB, we have our multi-model collection. So this is a DocumentDB collection. It's a collection of JSON documents. Nothing crazy yet, but I want to blow your mind here. So we're going to have some fun. First thing we're going to do is we're going to add some vertices using the Graph API. But Sidney, this is clearly is DocumentDB. This is not Graph. This is DocumentDB. Yes. But remember I told you earlier that you can start switching out APIs and switching out models on the fly. And that's where the real power in Cosmos DB comes in. So while this is technically Cosmos DB created using the DocumentDB API, that doesn't stop us from using the Gremlin API to query the same data set. Let's see an example. So I'm going to add a DocumentDB document. So await client.create document async. I'm going to use the special methods that DocumentDB gives us. So URI factory .create document collection URI, database name. So you've seen this already. Nothing new here. We're going to go in. We're going to create a new object. We're going to say first name equals Sidney, last name equals Andrews, ID equals Sidney Andrews .db. Run it. Go back in here, refresh. I collapsed that because I'm not using that database right now. And we have our document. Really simple. First name, last name, ID. It has some extra information, like on documents and DocumentDB can have physical attachments, files, timestamp, e-tag, self-reference. So this is actually a URL you can use to reference this if you're using the REST API, and a couple other interesting things here. Now, that's interesting enough, but I can take that same collection and add a vertex. So I'm going to go in, just like we did before. Client, well, actually, I'm going to strongly type this. So I document query, I type vertex, query equals client.create Gremlin query. I'm going to create a vertex query. Within here, I'm going to pass in my collection and a string representing the query I want to run. So for this, I'm going to say g dot, and let me get rid of this help, g dot add a person. So I'm going to add a vertex with the label person. I'm going to add the property ID, Sidney.Andrews. I'm going to add a property called first name, Sidney. Add a property called last name, Andrews. If I didn't have any typos, I'm going to go ahead and run this query. So await query.execute next async, vertex dump, and I already have a typo up here. Forgot all about that. Run it. I have a vertex called Sidney Andrews. So go in here and refresh this. There we go. I have a new DocumentDB document in my DocumentDB collection that represents a vertex that I can query using the Graph API. So you see here that the properties for the Graph API are really just an array. So you can have multiple values for the same property. So technically, I can have multiple first names. That probably not necessary, but I can have it. Last name, and then the same stuff you expect from DocumentDB. We can continue on. We can do, I'm just do a simple graph traversal here. So Kevin Griffin, Kevin, and I won't even include his last name. Run it. I now have a Kevin Griffin vertex. Refresh again. Kevin Griffin's right there. Perfect. I can do an edge query to create an edge. So here I'll say, g.v Kevin Griffin that add edge knows.to g.v Sidney Andrews. And when we use the v function here, we're really looking up a vertex using ID. Technically, it returns a list of IDs. Think about how jQuery works. But for our purposes, an ID matches one-for-one is globally unique. So we're fine using it in a query in a sense. So we create an edge. Oh no, I have I've forgotten something. Looks like I forgot to close the parentheses here. Also, there's another thing I always forget, to add a property called ID to my edge. Notice edges can have properties very much like vertices, excuse me. And I'll say Kevin knows Sidney. That'll be the ID of my edge. Run it. And we have an edge called Kevin knows Sidney with a label knows. The in vertex is Sidney, the out vertex is Kevin. So that means the line is going out from Kevin, going into Sidney. They're both people with the label knows and the ID Kevin knows Sidney. Let's look at the representation of DocumentDB. So you have Sidney, Kevin, and we have our edge. Kevin knows Sidney with lots of metadata indicating that this is an edge, not a vertex. So using this metadata, we can use DocumentDB to query our graph in a line of business way. So if we want to do things like maybe select all from graph. Let's see, I want to use DemoDB in the multi-model collection. Run a query, super simple. If we want to start doing things like maybe select, and I like to do this little spacing here, graph.id from graph where, let's see, graph.isEdge. So if it has the isEdge property and it's true, remember with DocumentDB, we can query on properties that don't always exist because of automatic indexing. We now have the graph.id for our only edge, or if we just want the whole thing, we have our only edge. So really interesting stuff. We can do the same thing, like maybe we want to do it based on labels. So graph.label equals person. We can definitely do that. And we have two people, Sidney and Kevin. Very simple. We can even go a little bit deeper. Maybe we want to structure this. We're returning it to somebody's API. So maybe we want to do things like maybe graph.label equals person. We can do, let's see, graph.id, graph.label, run it. We get this. That's nice, but maybe we want to form the data. There's a special syntax in DocumentDB called select value that allows you to flatten the results. And just like with SQL, you can actually use aliases using the as a keyword, but here you can also create JSON on the fly. So I could say identifier and entity type, run it, and now I have a custom formatted JSON array that could be useful. Maybe I just want to get the IDs as an array of IDs. I can do that too. Select value graph.id, and I just have an array of IDs. So this DocumentDB SQL syntax allows us to do a lot of crazy things. I want to show you a couple more crazy things we could do with this graph, and then I'm going to show you how we can traverse this graph query. So we can go in. One of the interesting things is we have this concept of join, but with no relationships. So what does that mean? Well, a join allows you to select sub-entities or sub-documents within a JSON document. So we have this first name, last name property, which is really a collection. We can query on that. So, for example, I would go in and start off with something like maybe graph label equals person from graph. I'll add a join statement. So join graph, let's see, join first name in graph.firstname. So I create a new entity called first name. Join, or let's just stick with that. And so we have graph.id, graph.our first name dot value. Actually, let me just do it there. There we go. So we have a collection of first name values. If we have more than one first name, we can do that. That's the beginning, but it can get really crazy. Like, let's say I wanted to get people's names. So select value. I can concatenate first name dot value, maybe a space, maybe a last name dot value as name. I could go, or I don't even need an alias because I'm just selecting the flat values. I'm going to add another join statement, last name in graph.lastname, run the query. I'm just running this. It's kind of funny because I'm actually running this off of memory right now. Sidney enters is the only person who has a first name and a last name. So that I'll be the only person who's returned. If I remove the last name join and the last name from this expression, it'll return both Kevin and I because we both have first name values. And there we go. So lots of interesting things you can do here. It can get really, really deep, and you can start doing some complex DocumentDB queries. But one of the other interesting things I want to show you is that we can do Gremlin queries and affect the results of the Gremlin query using DocumentDB. So I have my Gremlin query right here, and I'm going to create a Vertex query. But really, I just want to know who Kevin knows. So for Kevin, I want to go out on the nose edge and on the vertex to anybody who has a label person. So filtering to only vertices that have the label person, run it, And actually, I need to change my types. At F5, and it returns Sidney Andrews. So pretty cool. I could do things like maybe I want to get my values last name. I think I'd put a capital N. Apologies. And then instead of a vertex, it's going to return a string. So we'll just update our types here. F5. So Kevin knows Mr. Andrews. When, let's say my wife and I, we decide to change my last name, I can go in here, update this. So Andrews Jones or Jones Andrews, depending on who wins that argument, hit update. So we just did a DocumentDB update. You can use Link, you can use whatever you want using this DocumentDB SDK to do that update. I just did it in Portal because it was faster. Run this, and now my Gremlin query is going to return the correct data. So now we can actually do traversal queries on data and still manage them using more of a line of business syntax. If you take anything else away from today, it's that combination together is really interesting, and it gets even crazier. Maybe you want to create a cache based on the data in your DocumentDB database. So you want to take the data out in cache form and store it using key value pairs. You can use the key value API to access the data in your DocumentDB collection. You can continue to combine these models in really interesting and exciting ways. So the crazy thing about this is I prepare board demos, but it's just so much to talk about and so much to show. And this is just the beginning. These 4 APIs that we talked about are just the first APIs launched. More APIs are on the way. More combination of features on the way, integration points, so you can actually combine Cosmos DB into Apache Spark, regardless what API you use. You could combine Cosmos DB into Azure Search, again, regardless of the API you use. So learning Cosmos DB from a foundational perspective is going to be very important, because as new APIs come out, you can just implement them and try them out with very little change to your underlying data structure. So if you've made an investment in Cosmos DB, your application is using, let's say, DocumentDB or MongoDB API, and your organization is new to graph traversals, then you can experiment with it. You can use your existing data set or even just make a duplicate of your data set to give you an example to go into that. So there are lots of places you can learn more, and Kevin's going to help me out with sharing some of these links. So the first place is the documentation for Azure Cosmos DB. This is a new service. They completely revamped documentation to show you lots of different things you can do with the service. I've only scratched the surface. For example, the couple of Gremlin queries I showed you are just in the first 2 paragraphs on the Gremlin documentation page. I try to stick as close to those examples as possible, so when you look up the documentation, you're not completely lost. The rabbit hole gets pretty crazy. You can start to do things like continue to traverse in almost a recursive manner and find everybody who's related to a certain person based on those edges. So finding friends of friends or friends of friends of friends based on data that's in your structured data set. Again, you can combine these models together. Now, the next link I want to show you, and Kevin, were you able to share the link out for this one?
Yeah, everyone, it should have opened in a new tab for them, or it would have blocked a pop-up. One of the 2 options.
Depends on how aggressive your browser is.
Yeah.
The next one I want to show you is you're going to see in the Offers tab on the right-hand side, we are launching a Cosmos DB course on edX. I was just in Seattle last week with the Cosmos DB team. It was really amazing to get to sit down. We've met multiple times before, but being able to sit down with the principals for each API. Each API essentially has their own team trying to make sure that API works the best way they can. And then they have their foundational team working on a foundational service. And then they have teams working on APIs that we don't know about or people can't even talk about yet. That's the crazy thing about it. They see this as their investment in the future. And then as new APIs come out, as new data structures in the NoSQL world comes out, they could just implement the models and APIs that are most popular in the community. Microsoft hasn't really had an investment in the graph database space, but they saw that the community liked Gremlin, so they implemented a graph model and then the Gremlin API on top of the graph model, just so that now with Cosmos DB, you can use that. DocumentDB was already implemented. They already had a document model, and they had the DocumentDB API. they knew a lot of people used MongoDB, so they just added a MongoDB API on top of that document-based model. And you saw some models there that don't have APIs yet. You saw on the slide, we talked specifically about the column family model. Doesn't have an API yet, but that model already exists in Cosmos DB. This course launches on September 12th, 100% free online course. And I promise you, what I talked about today is just the surface. I spent last Monday, Tuesday in August in Seattle with the product team, and we got one of those big Surface hubs, and we recorded hours of videos of them diagramming and whiteboarding all of this and talking to you about from an architectural perspective why you would want to create a multi-model database and why you'd be interested in this and what the business value and proposition is. And they even talked about customers who are already using it, both within Microsoft and external, and business scenarios where we're already seeing people, flights, airlines, social, lots of business scenarios already digging deep into this. And they also talked about how even for simple scenarios, hey, we have a startup, we want to use MongoDB. Well, this is a fully managed service. And even if you don't care about multi-model or going all the way into the rabbit hole, if you just need a simple database to host a fully managed version of MongoDB, Cosmos DB is flexible enough to do that too. So we get to talk a lot about cool stuff like that. So we're right up to 2 o'clock. That's the end of my presentation. I saw a couple questions in the chat, but I'm here if you have any more questions.
So yeah, everyone, take a minute. If you have any questions for Sidney, let's ask them. I want to go ahead and take this opportunity to thank Sidney for being our scapegoat for our first SwiftKick webinar. He and I have spent the past 2 weeks testing different parts of this system to see what would work, what would not work, and we think we got all the bugs out. And we really appreciate you all coming out and joining us. And in about 2 weeks, we'll have our next webinar on September 6th. A good friend of mine, Brett Fisher, will be talking about Docker Compose. So if you're a fan of Docker, you have no idea what Docker is, it should be a good learning experience for everyone out there. And also, please go out and follow everyone on Twitter. First, Sidney. Sidney is at Sidney_Andrews. I am at @1 Kev Griff. And also follow SwiftKick at Team SwiftKick. And let's see. I don't see any questions coming in, Sidney.
I completely forgot it. I apologize, but I'm going to be talking about this a lot more coming up. At Ignite, I'm not talking about Cosmos DB specifically. I'm there talking about Project Centennial, WPF, on UWP, the future. So I'll be there doing a lot of theater sessions. But if you want to talk Cosmos DB, you're going to be at Ignite. I'm happy to sit down and talk with you. I know the product team. I'm happy to introduce you to them. They love talking Cosmos DB. It's their life. So they're going to be giving great talks at Ignite. I think many of the principals for the team are going to be there, which is shocking. Usually it's just technical people way up who make decisions are going to be there. I'll be at Pass Summit. Again, the same group is going to be at Pass Summit talking a lot about Cosmos. I get to talk about what we talked about today. They are introducing Cosmos. My talk at Pass Summit is going to be about going multi-model and really building ASP.NET applications that use multiple models of Cosmos DB. Somebody said the column model, is that like a traditional SQL database? Mike, the column model is something I'm not as familiar with, but I did a little work with it with Cassandra and HBase. It's a different way of doing NoSQL. I'm more from the key value and document-oriented NoSQL, but I'm going to share a link in chat for column-oriented NoSQL databases. And as always, you can just ping us if you have more questions, and I can actually connect you to people who know more about it. It's a little bit outside of my expertise, but it's popular right now, especially for you talking about Hadoop and other massive data systems. Column-oriented database management systems are pretty big. So the Cosmos team has heard everybody's, and they said, okay, we've already implemented the column model, and we're on our way to implementing column APIs. Expect to hear more about that in the coming months.
Alrighty. I don't see anything else coming through. This replay will go out to everyone in the next couple hours. So thank you for attending, and thank you for your questions. And again, thank you, Sidney, for a great presentation.
All right. Thank you, everybody.